everyone, welcome to Jinghua Education. I'm Steven. In this video, we're going to talk about Calculus 1, Derivative Tutorial Part 2, the interpretation of derivative. In Part 1, we've been talking about how to use a definition of derivative to find the derivative of each functions. And then we didn't really talk about why and how these functions come from. Okay, so right now we're going to talk about why we use this function here, where this function being created. Okay, good. So when I was tutoring UBC, there are students looking for me before the final exams. Even just like 3-4 days before final exams, they don't understand what it means of derivative. They know how to find the derivatives, but they just don't know what is derivative. Okay, so that is pretty sad, pretty much, right? So I'm going to show you what is derivative. I'm going to say it twice. Okay, derivative is what? Derivative is a function that collect every single point, tangent line, slope of the original functions. I say that one more time. The derivative is a function. The function is collecting every single point's tangent line slope of the original functions. Even I said twice, maybe it's not make sense to you. It's totally normal, okay? I will show you an example here. All right, so let me show you example. So for example, we have this curve here. You got the right line curve, okay? And then I'm going to draw a tangent line. I assume you know what is tangent line, okay? And then I can draw tangent line everywhere. Here, anywhere. So right now I'm trying to draw a tangent line at x equal to -1. How do we draw tangent line here? That is how to draw it. Okay, that is how to draw a tangent line. Okay, right now I am trying to looking for the tangent line slope here. Okay, so how do we find slope? We never learned these things. All right, so what else we can do? We can try to use other slope to estimate this one, to just try to do the best guess. Okay, what we have learned so far, we learned how to using the rise over run to find slope, right? The linear functions. Okay, what if I'm looking for this point here and this point? We got 2 points here, okay? And then I'm draw a line between these 2 points here, and then we got a slope like this, okay? When we have the slope here, we can use what we have learned rise over run method to find the slope of this line. Okay, this shouldn't be too hard for us, right? So this is just a linear function, right? Linear function equal to what? Equal to the slope of linear functions just equal to rise over run, right? Rise over run. What is rise? Rise is the y value differences. The run is x value differences. Okay, let's see if we got x here, and then we see entire things in here. It is h. Okay, so let's say here is x plus h. Okay, we can say that x is like h is negative number, so it's okay. We can just using x plus h. Okay, so on the other side is the same. So we got x and x plus h. That is the x value, right? At this point, x value is x. At this point, x value is x plus h. What's the y value? So we know this function is f(x) function, right? So this point, the y value is supposed to be equal to f(x) plus h. Okay? And then here, which is equal to f(x) only. Make sense? Good. Once we have x plus h and then x, the rise is just equal to f(x) plus h minus fx. The run is how much? The run is just x plus h minus x, right? The x value here minus x value here, which is x plus h minus x. Then we can just try to cancel the x and the x here. Make sense? Good. So that is the formula. Okay? However, let's see. The blue line and then black line is really like big differences of slope, right? It's not even close. So it is not good approximate. Then what do we do? We're trying to using not -3, we're using -2 here, this part. And then we connect this part and this part to make a line. Okay? So let's do here. Now we have another line. Clean up here, okay? So now we have this line. So we got here and then here. Okay? So now we have h as here. Okay? And then this part still x plus h. So this y value here is still here, is still fx plus h. So we found out actually from the green line slope, we can still using fx plus h minus fx. This is f plus h, and this is fx over h to represent. Okay? The difference is before the h is this part, before the h is this part, right now the h is only this part. Okay? Good. Okay, so the h is smaller, looking for the green line. Green line actually is to make more closer to the black line, right? Good. All right, then let's try one more times. Okay, right now we're trying to approaching the black line a little bit more. We're trying to making the h even smaller in here and then in here, okay? So I'm making this even half of h as like 0.5. Okay, I draw the purple line. See, the purple line is here and then here. So we got again, this part is h. Okay, so and then the purple line still is fx plus h, still minus fx here, right? Still minus fx over the h differences here. Okay, and then we see the slope is even closer to black line. Okay, now we learned one thing. So as long as the h is decreasing smaller and smaller, we can find the slope is closer and closer to black line. Okay, so what if we're making the h very small? How small? Approaching to 0. Then we are getting exactly these equations here. What this equation means is just for f prime of x. Okay, now we learn what is derivative. The derivative functions just are functions that help you to finding the tangent line slope for every single point. I say that one more time. What is the derivative? The derivative is a function. It's kind of like a tool to help you to find out or to approximate what is the tangent line slope at every single point. Now x can be -1. Later x can be 1, x can be 2, x can be any times, any numbers. Okay? So that is the interpretation of derivative. Derivative is nothing fancy. It's just a tool. Tool of what? Tool of help you to find out the tangent line slope at every single point. Okay, that is the means of derivative. Okay, I hope you understand this. If you have any questions, just comment below. I will answer in question in my next video. If you like, please subscribe. Thank you for watching.